Consolidated power projects is we do turnkey substations, and we go from a site full of trees and bushes to a completely built substation. Most of our customers are all over Africa, places like Botswana, Namíbia, Mozambique, Ghana, Uganda. Our division over here is mostly the protection and automation division, so we take care of the protection devices, protecting like primary equipment and things like that. The NamPower project was all focused around modernizing their transmission level substations. And they have a very distributed kind of country with a lot of deserts and lots of travel time associated when there's problems, so they wanted a lot to be remotely done.
A few years ago, NamPower approached Trans-Africa project in terms of coming up with a solution for their new substations. What they had in the past was a bunch of relays that had a large number of inputs and outputs that needed to be interfaced with RTUs and the likes, and all communications between the relays was of course done with hardwired interfaces as well. We decided to look at the current approach using the IEC 61850 standards in our substation automation.
At that stage the standard was still in its infancy. There was a lot of vendors that sold the product, made promises, came to do presentations.
So there was a lot of claimed compliance, but possibly where compliance did exist, the flexibility didn't exist. When we looked at the SCL products, that's when we actually found the best of both worlds. That's where we found the flexibility with the compliance meeting our requirements ideally.
The specification called for no generic input-output nodes available in the devices. This is where the SCL helped us a lot in the sense that we could remove all those and remodel them into something a lot more information-based. A lot of the other vendors were totally not capable of doing this.
That was another reason why the Switch Engineering Laboratories or cell relay was so well suited for this project, is that it allowed us to change ICD files where we needed extra, for example, extra goose messages or different configurations. Still staying with the standard, but just naming things in a way that we understand it better. So before we started with the implementation, we realized that we require a proper specification.
We wrote a specification looking at, of course, the protection side of what the IEDs needed to do. Ultimately, a protection relay needs to still operate as a protection relay, whether you have a communications infrastructure working or not. So to be honest, that really took first priority in terms of the evaluation of what products were to be used.
So we spent about 12 months just doing the specifications of what we expect from a 61850 substation, how we see the automation system, the protection systems, the control systems, how we will run our corporate services over these networks, voice over IP, security services. And in the new 21st century substations, most of your services is provided across the Ethernet network. You use Ethernet networks for protection tripping, for sending sampled values, for sending goose messages.
For the NamPower project, the key benefit of 61850 was the information that the relay would hold. Instead of just knowing something as a generic input, we could be able to know that this is related directly to a circuit breaker open contact, for example. Another capability that the SCL devices gave us was the ability to monitor all the goose information. Some of the other vendors have similar mechanisms, but they don't quite operate in the sense that they monitor, say for example, the network card and whether it's working, where the SCL allows us to monitor not only the network card, but whether each individual goose is operating and being received on time. And what this allowed us to do was alarm our important protection trips going by a goose all the way up to the SCADA control system, so that they would know there's a problem with the protection and that it's not going to function well before it was required to do so and failed. The goose allowed us to get rid of a lot of wiring. One of the key places in this was the buzz zone, where all the statuses and all the trips that the buzz zone would do would become via goose instead of hardwired.
We get access to information such as the sequence numbers and the state numbers and whether that message is being currently received or not. And of course all the other details that make up that goose message, such as the data set that is configured and so on. So having access to all of that kind of information makes it truly useful.
So we're very proud. We know we've done the right thing. It's a 21st century solution for 21st century substations.